All right. Hello. Welcome back. Okay. So we are starting with chapter 3, 3.1 reference angles. So take notes. Hopefully, you are keeping up with the homework and make sure you are checking in for attendance on Canvas every week. All right. So we are covering reference angles today. Uh, this will be in, I don't know, 2 or 3 videos. We'll see. We got a lot to cover here. Okay, so let's just kind of note that previously in the other chapters, when we looked at the 6 trig functions, we took the 6 trig functions of only acute angles. I'm going to use this symbol for angles so we don't have to write so much. So now, except if it were like the quadrantal angles, 0, 90, 180, 270. Okay, so now we are going to be doing the 6 trig functions on any angle by using the reference angle. So we are going to talk about this wonderful thing called the reference angle. Okay, so what is it? The reference angle. So now, like, before memorized, you guys memorized like sine, cosine, and tangent of 30 degrees, 45 degrees, 60 degrees. And so now here, we're still going to be using those. So hopefully you still remember what the sine, cosine, tangent are of those 3 angles. Okay, so because they play a big role here in finding the trig functions of non-acute angles. So maybe like 135 degrees. Okay. All right. So reference angle. So for any angle, in standard position, it is the positive acute angle between the terminal side and the x-axis. Okay. And the notation we use, depending on the book you use, this book is going to use theta hat because it looks like it's wearing a little party hat, right? Okay, so or old school, I guess, used to use this theta prime. Okay. All right, so let's read this little definition here about what a reference angle is, and let's kind of dissect it. Okay, so for any angle in standard position, it is the positive acute angle. So you must be wondering, okay, wait, I thought we were going to find the 6 trig functions of angles that are not acute. Okay, so yes, we are. So like 135 degrees, right? Not an acute angle. Acute angles are between 0 and 90. Okay, like 30, 45, and 60. Okay, so here, when it says that it's the positive acute angle, so you can't just read that part without reading the rest of it. So it is the positive acute angle between the terminal side and the x-axis. Okay, so one thing you have to know about reference angles, they are always acute. And so that is going to be the connection between these 30, 45, and 60. Those are all acute. That's this here, reference angles being acute. That's going to be the connection to these 30, 45, and 60. Okay, so it's always acute, and it's always measured from the x-axis, not the y-axis. And we're going to add something in a minute there. Okay, so leave some space. All right, so let me give you a visual of what we're talking about. Okay, so suppose we're talking about something like 135 degrees, right? 135 degrees is definitely not acute. It's more than 90 degrees, right? So let's imagine an angle like that, okay? So when we talk about the acute angle, then we're talking about the angle that's formed, according to this definition, it's formed by the terminal side of the angle. So this is the terminal side of the angle and the x-axis. So if we have here the x-axis, right, then this here, this angle here would be the reference angle, okay? Same thing if you have an even bigger angle. So let's suppose you go like this, and then you go all the way around to here, right? So that here is your terminal. This is theta, okay? So then theta prime or theta hat is this one right over here, this acute angle that is formed by the terminal side of the angle and the x-axis, okay? I'll do that. Okay, so let's take a look at some actual concrete examples. Okay, so with some actual numbers. All right, so let's take a look at this one. Suppose that we have this non-acute angle 135 degrees, right? Okay, so let's take a look at the reference angle. Well, if we draw it, right, so here is my x-axis, y-axis, so that's 0. Okay, hold on a second. My mouse is trying to steal the attention from my from my stylus. They're kind of having a battle here. Okay. All right, let's see. This is 0 degrees, 90 degrees, 180, 270, right? Okay, so 135 degrees is in quadrant 2. Okay, so this is theta, which is 135 degrees. Okay, so my reference angle, here, maybe I'll use a different color since I can. Okay, so the reference angle is going to be this angle measurement right over here. And this here is going to be theta hat. Okay, if you're, again, it's theta, the little party hat. Okay, and we call that theta hat. Okay, all right. Okay, so if we're trying to find the reference angle, that's this angle right in here, then we can see that this angle right here is just going to be 180 minus 135, right? Okay, so let's go ahead and write that down. Okay, so theta hat, our reference angle, is going to be 180 degrees minus 135 degrees, and that gives us 45 degrees, which we have memorized the sine, cosine, and tangent of 45 degrees, right? Sine of 45 degrees is, let me hear you say it. Okay, it is square root 2 over 2. Cosine of 45 degrees is square root 2 over 2. What about tangent? Tangent of 45 degrees is 1. Okay, so you can see how those those three angles, 30, 45, 60, are going to play a role in finding the sine, cosine, tangent of these non-acute angles, like 135 degrees, okay, because now anything that has a reference angle of 30, 45, or 60, you will also know the sine, cosine, tangent of those, okay? So long as their reference angle is 30, 45, or 60. Okay. Okay, let's take a look at another example. We're not gonna go into evaluating these just yet. Let's just practice looking at how to find them. All right, so let's suppose that we have theta is negative 140 degrees, okay? All right, negative 140, so we have 0 here, negative 90 here, negative 180, and negative 270, because negative angles go clockwise. Okay, so negative 140 is in quadrant 3. Okay, so we are over here. Okay, and this is negative 140. Okay, so over here, we want the reference angle right over here. Okay, so here, we're going to do theta prime. Here, let me use my purple here. So theta prime, theta hat is going to be that angle right over there. And we see that that is going to be the difference between negative 180 and 140. Okay, so let's take a look. Negative 180 minus negative 140, and we get negative 180 plus 140, and that gives us negative 40 degrees. Aha, but wait, let's take a look up here at our definition here. So our definition here says for any angle in standard position, it is the positive acute angle between the terminal side and the x-axis. Okay, so let's add that as our third always. Okay, so it is always positive. Okay, always positive. So over here, it's not negative 40, but positive 40. Okay, so now we can't use equals because negative 40 and 40 are not equal. So let's do this. Let's turn these all into arrows. And now we can say theta hat equals 40. Okay, so let's put a note here. Note, reference angles are always positive. So you can just take the absolute value. Okay. Okay, so go ahead and try these. Try to find the reference angle for each of these. All right, so try. find the reference angle. Oh, so you might be asking, okay, well, that's 40. That's not 30, 45, or 60. Okay, so yes, it's not one that we memorized, but it is still the reference angle for negative 140 degrees. It still has, they all have reference angles, okay? Whether or not it's an angle that we have memorized, it doesn't matter. Okay, so it would be nice if I asked you to evaluate the sine, cosine, tangent of this non-acute angle, and it has the reference angle of 30, 45, or 60, but it isn't necessary. Okay, it's just that the ones that do have reference angles of 30, 45, or 60, you'll be able to answer those, okay, without a calculator. So here you would have to use a calculator. Okay, so find the reference angle of this one, 240 degrees. And here, I'll put it over here. And negative 210 degrees. Okay, so go ahead and hit the pause button and come back to see if you got the same answer as me. Okay, so 240, I always like to draw these. That way it makes some visual sense to me. 240 degrees, so this is 0, 90, 180, and 270. Okay, so I know that's going to be over here in quadrant 3. Okay, so that's going to be somewhere in here. This is 240 degrees. And so what I'm trying to find is this itty bitty angle that's actually in, where can I draw it? I don't have any room. Okay. This piece right here is going to be my theta hat. Okay, so here, doing a drawing also helps me to figure out what numbers am I subtracting to get the answer that I want. Okay, so if this one's 240, I can see here that my reference angle is going to be theta hat is going to be 240 minus minus 180. Like I can visually see that from my drawing. So that's why it's always helpful to do one. Okay, so when I do that, I get 60. And that is one that we have memorized. So here you would be able to answer the question, what is the sine of 240 degrees? Okay. You would actually be able to find the sine, cosine, tangent, all 6 trig functions of 240 degrees, because you have 60 memorized, and 240 has a reference angle of 60. Okay, but we're not there yet. Okay, right now we're just trying to find reference angles. Okay, negative 210 degrees. So here's 0, negative 90, negative 180, and negative 270. So negative 210 is somewhere in here. And we see that all the way from here to here is negative 210. And we want just that little sliver of an angle. This piece right here is going to be my theta hat. Okay, so I can see what I'm going to need to subtract here. So I am going to have to do negative 210 minus negative 180. You know what? I'm not going to do this, so I don't have to worry about those arrows. Okay, so negative 210. This equals negative 210 plus 180 and this equals 30, negative 30. Okay, but we want the positive outcome, so now I'm gonna say theta hat equals positive 30, and that is something that you guys have memorized as well. Okay, and so you would be able to find this all 6 trig functions of negative 210 degrees. Okay, again, we are not quite there yet, so let's just kind of focus on how to find the reference angle. Okay. All right. So in general, so some students have a hard time making sense of the drawing and understanding what they're subtracting and what order they're subtracting. Like this here doesn't make a whole lot of sense to them. Okay, so if that's the case, then you could always just memorize this. To me, it makes it's a little easier just to do the drawing and then logically figure out what to subtract. So if theta lies in quadrant 1, then we don't have to worry about the reference angle, right? The reference angle is going to be the same as theta, okay? Because in quadrant 1, you're still in acute angle. Okay, but if your theta is in quadrant 2, so some angle between 90 and 180, then in order for you to find theta hat is 180 minus theta. Okay, if you're in quadrant 3, then theta hat equals theta minus 180. And if you are in quadrant 4, then theta hat equals 360 minus theta. Okay, so maybe that is helpful for some of you. You don't have to memorize this. You don't even need to know this if doing the drawing makes sense to you. Okay. All right, so we have a reference angle theorem. Okay, so reference angle theorem. Reference angle theorem. Okay, so a trig function, so like sine, cosine, tangent. So a trig function of an angle. So the sine, cosine, tangent, cosecant, secant, cotangent of an angle and its reference angle are the same. Okay, so except possibly for the sine. Not sine, S-I-N-E, but for the sine, like positive, negative. Okay, so let's go back up here at some of these examples that we did. Okay, so what they're saying is, let's go back to the theorem. It says a trig function of an angle and its reference angle are the same, except possibly for the sign, positive, negative. Let me do that. Okay, so positive, negative. Okay, so they're saying they're the same. If you take one of those 6 trig functions of that angle it's going to be exactly the same as that same trig function of the reference angle. So if I take a look over here, we see that negative 210 degrees has a reference angle of 30 degrees. Okay, so over here, the sine, cosine, tangent of negative 210 degrees will be exactly the same as the sine, cosine, tangent of 30 degrees, with an exception of the sine. So we know sine of 30 degrees is going to be 1/2. So the sine of this could be 1/2 or negative 1/2, right? We'll take a look at, well, how do you know which one it is? So we'll look at that next. Okay. Cosine of negative 210 degrees will be the same as cosine 30 degrees, which is square root 3 over 2. Okay. But it could be either positive square root 3 over 2 or negative, depending on where you land, which quadrant you're in. Okay. And then same thing with tangent. Tangent of negative 210 degrees will be the same thing as tangent of 30 degrees, with an exception of the sign. It could either be positive or negative. Okay. Same thing with this one. The sine of 240 will be the same as the sine of 60. Okay. But positive or negative. Okay. The cosine of 240 will be the same as the cosine of 60. The tangent of 240 will be the same as the tangent of 60. Okay. All with the possible difference of the sign. Okay, so how do we know what sign, if it's going to be negative or positive? Okay, well, that goes back to the quadrants, where sine is positive, which quadrants are cosine positive, etc. So let's just revisit that from before. So here's our x-axis, here's our y-axis, and we know that sine is associated with the y values, right? Sine is associated with the y values. So up here, the y values are positive up here. Down here, the y values are negative. So over here, sine is associated with the y values, so sine will be positive here, and sine will be positive here. But down here, the y values are negative, so sine will be negative here, and sine will be negative here. Okay? And so, so this means if you're doing the sine of a non-acute angle, so let's take a look up here. Let's do this one, 240 degrees. 240 degrees lands down here. So if you're going to do the sine of 240 degrees, that's the same as sine of 60, with a possibility that it could be, negative or positive, right? So here, 240 degrees, over here, reference angle 60, sine is negative, so here it would be not positive square root 3 over 2, but negative, because sine values over here in this quadrant are negative. Okay, so when you find the trig function of these non-acute angles, it's going to be very important that you know which quadrant they land in, so that you can figure out the sine. Okay, so if you do the sine of this angle here, we know it lands here, so the sine will be negative. If you do the sine of this angle here, it lands up here, and so we know the sine will be positive. Okay, because sine is associated with the y values. Y values are positive here. Y values are negative down below. Okay. And let's do the other two trig functions. Cosine. Cosine is associated with the x values. And so all the x values are positive here and here, right? On the right-hand side. All these x values are positive. All these x values are negative. So negative here and here. So cosine is positive here. Cosine is positive here. but cosine is negative over here and negative over here as well. Okay, and then tangent is just sine over cosine. So just by looking at these here, we can see positive over positive, positive over negative, negative over negative, negative over positive. So we can see here that tangent will be positive, tangent will be negative, tangent will be positive, and tangent will be negative. Okay? All right, so let's take a look at actually evaluating some of these non-acute angles now. Okay, now that we know how to find reference angles, and now that we know the signs of the trig functions, sign meaning positive, negative. Okay. All right, so let's do these. Find the exact value of sine of 240 degrees. Okay, so let's take a look here. All right, so again, I like to draw these. I think it's important to know which quadrant they land in. So let's see, 0, 90, 180, 270. Okay, so 240 is right in here somewhere, quadrant 3. Okay, and so we know that the sign in this quadrant is going to be negative. So our answer should be negative. Okay, we need to find the reference angle. So we know this big angle is 240. But what we want is the reference angle, which is this little sliver right here, theta hat. Okay, so we are going to do 240. So theta hat is 240 minus 180. Okay, and so this here is 60 degrees. And we know what the sine of 60 degrees is. Sine of 60 degrees is square root 3 over 2. Therefore, sine of 240 degrees will be not positive square root 3 over 2, but negative square root 3 over 2. Okay, so there are some things you have to keep track of. You have to keep track of the quadrants so that you can keep track of whether or not your final answer is going to be positive or negative. Okay? All right, let's try this one. If you want to try this one on your own, you can. All right, let's see. Find the exact value. Okay, so a note about the wording of this question. Find the exact value of secant 300 degrees. Okay, so when they say find the exact value, if you recall, they mean to give us the square root answer, okay? Not the decimal answer, because these are all irrational answers. Okay, so these are irrational. And so if you try to give us the decimal answer, you're never going to give us the exact decimal answer, because your decimal answer, because it's irrational, will go on forever and ever and ever. So if you cut off your decimal answer, then that means you are not giving us the exact answer. You're giving us a rounded answer. Okay, so when they say exact value, they mean give us the radical answer. Okay, the square root, the answer with the square root, not the decimal. Okay, so find the exact value of secant 300 degrees. All right, so we have 0, 90, 180, 270, and 300 is in here. This is kind of boring. I mean, not this like trig, but not math class. This problem, because we just did a 60. I didn't realize that I did a 60. Okay. So this is 300 degrees. And so my reference angle is this angle right in here, theta hat. Okay, so theta hat is going to be 360 minus 300. So theta hat is 60 degrees. All right, so secant, which is the reciprocal of cosine, we know cosine here is positive. Okay, so my final answer here will be positive. All right, so let's see. Cosine of 60 is 1/2. Therefore, secant of 60 is 2. And so secant of 300 must also be positive 2. See how that works? We need to find out the quadrant in order to find out the sign of our final answer, positive or negative. Okay. Okay, so that is it for part 1. Stay tuned for part 2, where we use coterminal. We talk about coterminal angles and some other good stuff. Okay.